Hello, this Toolbox talk is brought to you by Changemaker 3D, providing you information on 3D concrete printing and examples of the work that we undertook with the Water Industry Printfrastructure project funded by Ofwat and delivered in partnership with United Utilities, Scottish Water and Manchester Metropolitan. What is 3D concrete printing? You may have heard it referred to as additive manufacturing in construction or 3D construction printing. All three names mean the same technology that is using a robotic system to layer and extrude 3D material in a precise pattern without the need for traditional formwork. You may have seen examples online of homes and infrastructure assets being printed. Unlike conventional construction, where concrete is poured into moulds, the 3D concrete printing robots print directly onto each layer using a nozzle controlled by software. This software is underpinned by a design code that the printer then interprets into the pattern that needs to be printed. But what does a concrete printing robot do? There are two main types of robot that you may have seen online or you may want to do some additional research on. These are gantry systems. These are fixed frame robots that move along rails and are great for printing large scale structures like houses or building components. An example of something you may have seen online or may like to research would be a Cobod 2 printer. There are also mobile robots, like the Cybe construction printer you can see in the picture. These are often on tracks, they have a limited print range of around 3 to 5 metres, and they can be positioned very flexibly on site or off site. Both types of printing system are controlled through an extrusion of material that is precisely deposited in a specific design. As you can see here, this robot is layering up exactly what is needed for this distribution chamber. How are products created? A design file, once approved, is sent to the printer. The printer receives this design file in something that may be specific to that robot. It may be a chisel software, it may be through Rhino software or AutoCAD. There are many design files available that can interface with lots of the 3D concrete printing robots available on the market. Whichever chosen method you are utilising, that design file is sent across to the printer, where it then converts that file into a G-code. The G-code, in this instance, operates an instruction every half a centimetre. That means that the robot is printing and having instruction for printing every half a centimetre, which allows for two things: accuracy, but also a blueprint on a design file for what was anticipated to be printed versus what was printed. And this provides really good data for quality assurance and product inspection. Once the printer is operating, it will then print through a dry run to make sure that there are no adjustments that need to be made for calibration onto the ground or onto a base slab. After the dry run, the material is then sent through into the pipes and extruded down into the robot. Depending on the type of robot that is being operated, there will be speeds varying typically around half a metre per second. This can be much slower if it is a large gantry printer that may be printing across 10 or 12 metres. It can be up to half an hour. by the time that that robot has done one loop of a large gantry printed structure, for example. But typically, like in the picture you can see on the screen, you're anticipating 3 to 5 minutes of setting time and a speed of half a metre per second on extrusion. A basic structure, like the one you could see in this picture, could be printed in under 2 hours, but typically between 2 to 4 hours, with some additional time allowed for finishing works, such as inserting lifting anchors. Safety considerations underpin all 3D concrete printing activity. It is very important that human-robotic interfaces are appropriately and fully risk assessed. It is important that whichever 3D concrete printing robot and material are being used, in whichever environment they're being used, are assessed on the merit of that environment and the constraints associated with it. Typically, we anticipate safety measures such as exclusion zones, where no unauthorized personnel would enter into the robot's operating zone. There would be a requirement for qualified operatives. Only trained personnel should be around the robot and handling materials. Aspects such as emergency stop controls and multiple routes to disabling the robot must be in place, and all personnel must be aware and have access to them prior to any printing being undertaken. PPE is a requirement in the standard operating process in the UK, including hard hat, safety glasses, high-vis vests and trousers depending on the site that you are operating on, gloves, steel-toe boots, and considering respiratory protection if dealing with the materials and the mixing elements. We recommend a banksman that is overseeing the robotic activity in a similar manner to that of plant operations in the UK. We also encourage consideration for crush hazards, understanding the area in which the robotic arm or the gantry would be moving within, and ensuring that there are exclusion zones that could prevent people from being in hazardous areas. We are seeing in the UK an increasing interest and adoption in 3D concrete printing, and there are many technology benefits and impacts to be gained by continuing to adopt this technology. The technology itself enables and supports faster construction. It helps to significantly reduce build time, particularly when on site and being able to print in situ. There is less material waste. The machinery is able to print only what is needed. There is more design freedom, enabling complex shapes without expensive formwork, enabling designers and engineers to rethink the way that traditional structures are now designed and built. Sustainability. The material itself can be recycled. There are also opportunities to develop recycled printed materials, and there is a reduction in carbon because of the whole life cycle benefits, from logistics through to reduction in material, less waste, potential to remove rebar, and also the potential to use lower carbon materials as well. There are cost savings linked to lower labour and material costs in the long run. However, it is important to note that this technology is not here to replace the workforce, but to work alongside it, and to allow the skilled workforce and the labourers already on site to be redistributed into areas where they can add most value and support productivity. Water industry infrastructure future skills model. It is important to highlight that as the emerging technology continues to become established in the UK, there is an increasing opportunity for a diverse range of jobs and skills in our construction industry. These jobs include 3D concrete printing operatives who are on-site or off-site printing assets. There will be concrete technologists who can develop better printing materials, who can help us to push the boundaries on strength and sustainability. There will be software and CAD designers, including elements such as BIM, whether that's structural or civil engineers, who have an important role to play in the design of future assets. And construction engineers, who may specialise in digital fabrications, who want to incorporate this technology into their programme and into the structures and assets that they can help to deliver. There are also on-site maintenance technicians. These are people who may be maintaining the robots, or who in fact may be maintaining the assets that the robots have printed over time. It is important that the skills and jobs created through 3D concrete printing have an alignment to a skills framework. We see this as three key areas: being able to have a basic 3D concrete printing operative, having advanced printing techniques, and having digital construction skills. So these include things like being able to set up the machine, handle materials, and understand safety procedures, through to printing complex structures, troubleshooting and maintaining the robots. And then into things such as understanding the CAD software, increasing automation, and looking at robotics programming. As these emerging jobs come into our industry, it is really important for them to have alignment to the CSCS levels. On the screen in front of you, you can see how we have set out a broad alignment with the 3D concrete printing technical skills and competencies and where they would align with the CSCS levels. For example, a green card for a labourer would provide entry-level operative assistance in material preparation and site setup. A skilled worker card could be aligned to an operative 3D concrete printing, following technical drawings and ensuring quality control. The supervisory or gold card would be managing printing operations, overseeing safety and leading teams. The managerial black card would be planning large-scale 3D concrete printing projects, integrating automation with traditional construction and ensuring compliance with regulation. Additionally, there is alignment to apprenticeship degree levels, with level 2 to 3 apprenticeships, understanding the fundamentals of construction and the printing machine operations and safety, through to a 4 to 5 level higher degree apprenticeship, introducing the digital fabrication, the structural analysis, and some of the project planning associated around managing humans and robot interfaces, through to a degree level with focus on material science, automation, and larger scale construction methodologies. An example roadmap to new skills and 3D concrete printing jobs could be as set out on screen. Thinking about an entry level, particularly for a young person or somebody who is re-entering the industry after a break. Gaining foundational knowledge in construction and the machinery operations. Somebody who may have been in the industry for 2 to 5 years may then progress into specialising in digital construction techniques, troubleshooting, automation and design. Beyond that, with 5 years or more experience, it could be that you move into supervisory, engineering and or research roles in 3D concrete printing innovation. Water industry infrastructure design module. When addressing the design requirements for 3D concrete printing, we recommend that this is taken from a first principles basis and that material science is used to address the design codes that are applied to any design of any structure, whether that's in housing or infrastructure. We then recommend that the manufacturers of the materials are consulted and that data sets are used from UCAS accredited sources. This enables the designers and the engineers to have a baseline position of the material performance from which they can apply their factors of safety and undertake finite element analysis. On the screen in front of you, you can see cube test results which have been undertaken in a traditional manner in the UK by pouring 3D concrete printed material into a cube box container that was then tested and crushed by companies such as Socotec. You can see there that the crush data is in alignment with and supports that particular material data set. You can also see an example of some of the design codes that are used within the design principles and the design planning stage. You can also see on the screen some of the environmental testing and data sets that are recorded through robots, including things such as humidity, air temperature, water temperature, speed of robot, and speed of layering. All of these factors help to inform the design process, thinking about the way in which the robot has free form, but also understanding its limitations, particularly whether it's a robot or a gantry printer. Considering whether you are designing for a single structure or a modular structure. Considering design details such as interfaces, joins, and how the asset will interface with traditional construction materials and assets. Material science is a huge area and a huge topic within 3D concrete printing, and this module really is to raise a level of awareness, and we recommend that you take additional time to research and explore 3D concrete printed materials through access to the manufacturers online that are available with this information. It is important that all design processes and practices are underpinned by quality and standards. We recommend following the ISO 52939 that was specifically created for additive manufacturing in construction or 3D concrete printing. You can see on the screen an example of a production process or a pre-processing workflow, but there is much more detail to be found online at ASTM, where you can see the full requirement and specification for following this standard, including how to ensure the design and material quality is upheld. Thank you for taking the time to listen to this Toolbox talk. We hope that you have been able to take some information that is useful to you in your current understanding of 3D concrete printing. And if you would like to ask further questions, you can do so through the email on the screen. Thank you.